Welcome to the webinar on mitigation and adaptation of climate change. We're basically going to be focusing on the differences between these two terms in terms of their focus and objectives. What is the difference between building resilience and going green? Why do we need to pursue both of these strategies? How might synergies be created between these two strategies? And how might they be implemented at multiple scales, going from the local to the global? I'd like to start by looking at the basic dictionary definitions of these terms, because it gets a bit convoluted when we get lawyers involved at the United Nations coming up with rather difficult definitions. But if we take a look at the basic meaning of the word adaptation, it means becoming adjusted to new environmental conditions, undergoing modifications so as to fit new circumstances, a change or the process of change by which an organism or species becomes better suited to its environment, and the modification of an organism or its parts that make it more fit for existence under the conditions of its environment. So if we think about bears, most bears are black or brown, but we have the polar bear, which because of the environment in which it lives, has developed certain adaptations, physical adaptations. The white fur, for example, allows them to sneak up on prey. The walruses and seals never see them coming in a white Arctic ice pack environment. But the fur also allows solar radiation to penetrate through to their skin, which is a very dark color. They have black skin, which because of that dark color absorbs the energy, and that heat is trapped by the white fur, and so they actually have their own greenhouse going on. You can read about some of the other adaptations on here. If we take a look at some other definitions, Ian Burton in his video talks about adaptation, summing it up as finding ways to deal with or cope with climate change impacts. And then we have the official UN definition, the process of adjustment to actual or expected climate and its effects. In human systems, adaptation seeks to moderate or avoid harm or to exploit beneficial opportunities. In some natural systems, human intervention may facilitate adjustment to expected climate and its effects. Or to sum it up, adaptation is all about building resilience. If we go to Vietnam, for example, Vietnam is experiencing stronger storms. They're experiencing hurricanes hitting in places where they didn't normally hit, further south. And what they're doing in Vietnam to adapt to these changes is to plant and to leave in place mangrove forests along the coasts. They'd been clearing mangrove forests for economic development for many years because it wasn't really considered to be an economically active, let's say, environment. But as they found with stronger storms, they're getting a lot of storm surges, a lot of wave action that's causing erosion and destroying their coasts. And so mangroves play an important role in reducing the effects of climate change, of those storms. So they basically hold the sand and the land in place and act as a buffer to those waves coming in. Other examples of, let's say, climate change impacts and how we need to be adapting to them are changing temperature and precipitation patterns, both spatially and temporally. We're finding higher temperatures in places that didn't experience them before and at different times of the year. The same thing with rainfall. For example, in Bolivia, rainfall used to begin in September and last until about February. Now the rainy season is much shorter. The rains sometimes begin in December and peter out mid-February. And you get all of that rain at the same time. So we're ending up with, basically the same average, but falling in a much shorter period of time in torrential rains. And so how can we adapt to that? An example from farming is changing the varieties of crops that you're planting, perhaps planting something that is more resistant to higher temperatures, is able to withstand long periods without water, and also changing the planting time. Rather than planting in September, a lot of farmers are planting in November and December now. And by using better agricultural techniques, farmers can use less water to get the same yields. For example, in places with extreme drought, they're using up their water a lot faster. And so by using a more efficient watering technique, perhaps drip irrigation, for example, rather than flooding the entire field, you can get the same grain yield using half the water. Okay, now mitigation. Let's take a look at some of the basic dictionary definitions. To mitigate means to make something bad less severe, to lessen the force or intensity of something unpleasant, the action of reducing the severity, seriousness, or painfulness of something. And it might be helpful to look at the opposite meaning, exacerbate, or to make something worse. Ian Burton sums it up as mitigation is basically controlling climate change with anthropogenic or human-caused climate change. If we treat it as a pollution problem and try to reduce that pollution, that's one way of mitigating climate change. And the IPCC's official definition of mitigation is that it means implementing policies to reduce greenhouse gas emissions and enhance carbon sinks. Carbon sinks are basically ways in which you can take carbon out of the atmosphere and put it into a solid form. So taking carbon dioxide, for example, through photosynthesis, trees, forests play an important role in absorbing that carbon dioxide from the atmosphere, putting it into a solid form as carbohydrates, as cellulose in their bodily tissues, and in the right conditions, they may actually become fossilized in the Earth's crust. So to sum it up, mitigation basically means going green. I like this diagram. I'm going to bring up a higher resolution of it. On the left, we have where we've been since the dawn of the Industrial Revolution and all of the problems that has brought with regards to emissions, particularly emissions of greenhouse gases. And in the middle, we have a lot of the different, let's say, activities that need to take place in order to produce the future that we all want on the right, in terms of the different types of technologies that we need to adopt and changes we need to make to our lifestyles. This I got off of the internet. This is sort of sums up some of the strategies that we may adopt. Much of the, let's say, greenhouse gases we're emitting to the atmosphere, a lot of the anthropogenic climate change is due to our production of energy that releases carbon compounds, particularly CO2, to the atmosphere. So reducing our energy needs, recycling is an important part, but then also looking towards alternative energy sources. And you may or may not agree with all of these, but these are examples of sources that do not emit CO2 to the atmosphere. And they all may have positive and negative, let's say, aspects in and of themselves. I like this diagram because in terms of talking about strategies for climate change, it's a nice flow chart that gives us a sense as to where each of these strategies is aiming. If we go through the flow chart, we see that human-caused greenhouse gas concentrations in the atmosphere are causing the atmosphere to trap more heat and increase the temperature of the planet, called climate change. Climate change is resulting in impacts that we've talked about already, many of them very negative impacts on people, and the question is, how are we going to be responding to that? On the left, mitigation is essentially going to the root of the problem, trying to reduce the amount of greenhouse gases that we're putting into the atmosphere and enhance sinks. So, do things that are going to be pulling carbon out of the atmosphere, like leaving forests in place, planting trees, a lot of different things that we can do to pull greenhouse gases out of the atmosphere. And on the right, adaptation is basically just reacting to the impacts. How are we going to cope with in order to moderate harm or exploit beneficial opportunities? Now the question is, why do we need to pursue both mitigation and adaptation strategies in the face of climate change? Who needs to and where? Climate change is real, and it's like a moving train. Even if we were to stop all emissions tomorrow, the climate would continue to warm for a particular amount of time. There's a certain momentum built into the climate system. And so there's no question that we're going to have to come up with adaptation strategies, but those adaptation strategies are probably going to fail miserably if we don't work heavily on mitigation strategies as well, so that global climate change doesn't go completely out of control. Now, who needs to do this and where? This is a cartogram of global CO2 emissions, and a cartogram basically changes the size of a country based on a particular variable. In this case, the bigger the country, the more CO2 emissions are being emitted. And so you see the three main centers, North America, Europe, and East Asia, are the three main, let's say, emission points. And the countries that you're going to be visiting, here we have Vietnam, Morocco is somewhere here, and Bolivia is just a tiny dot on the map down here. And yet these are the countries that are going to suffer the most from the effects of climate change. This is a diagram from the Food and Agricultural Organization of the United Nations. And I would like you to take a critical view of this, looking at the differences between how they depict mitigation and adaptation. Particularly talking about which countries need to be involved in each of these activities. I get a sense that it's somewhat north-south, rather north-south dichotomy. And you also have this dichotomy between something being global in nature and being local in nature. Are mitigation and adaptation mutually exclusive? Or might there be synergies between them? Can you actually have both occur at the same time with the same project? Because oftentimes mitigation and adaptation are considered to be separate boxes. How can forests play a role in both mitigation and adaptation? Is there room for scales between the local and the global? And is there such a clear-cut north-south dichotomy? I like this diagram because it actually has a lot of overlap between the two. And so it allows us to think about the ways in which mitigation and adaptation intertwine and overlap and play out at multiple scales. So the overlap includes things like green infrastructure, power system resilience, sustainable transportation, water and energy conservation, building weatherization. All of these are examples of both mitigation and adaptation happening simultaneously. Let's take trees, for example. How does planting trees and conserving existing forests help to both adapt to and mitigate climate change? Well, we know that trees, forests, green plants in general pull carbon dioxide out of the atmosphere and put it into a solid form as either carbohydrates, fuel, or as cellulose that are bodily tissues in and of themselves. And what about forest soils? Forest soils are very spongy, oftentimes very rich in organic matter, and they can retain a lot of water. And in the face of climate change, that's also an example of mitigation, of adaptation and mitigation. A lot of carbon can go into those soils in a solid form, but they can also hold on to a lot of water and allow us to adapt to climate change. And so, when you're in the face of drought, for example, forests can provide a lot of water. They can protect watersheds, and they're also really good at providing shade. They actually can create their own microclimate. And so you'll find that forests can actually help out with regards to agriculture.